Hey Bobcats, this is Mr. Peterson. We're about to serve up a big cup of awesome in complex numbers and roots. Today we'll be looking at how we can solve quadratic equations with complex roots. Alright, so first things first, we need to rewrite this equation so that it equals 0. So 0 is equal to x squared minus 2x plus 5. Alright, we're going to need to do some completing the square action on this guy. So we take 5 away from both sides, and we wind up with a negative 5 is equal to x squared minus 2x. Alright, now we need to complete the square, and just a quick reminder, to do that we do b divided by 2, and then we square it. So b in this case is negative 2. Negative 2 divided by 2 squared is positive 1. And we need to do the same thing to both sides. We add by 1 over there, and we get that now negative 4 is equal to x squared minus 2x plus 1. Alright, and now we're ready to rewrite this as a square binomial. So this is x minus 1, the quantity of all that squared, equals negative 4. And you probably see here our next step would be to take the square root of both sides, but that's going to lead us to some trouble here because of this negative 4. Well, don't worry, we know how to deal with this now. This is really the square root of negative 4 equals x minus 1. And we know from our previous lesson that this is really negative 1 times 4 underneath the radical. Alright, negative 1, the square root of that, that's our imaginary unit. That's I. And the square root of 4 is 2. So over here we have a 2i, and don't forget the plus or minus. Plus or minus 2i is equal to x minus 1. We add 1 to both sides, and we are done with this problem because we get 1 plus or minus 2i is equal to x. Alright, let's look at this bad boy over here. We got g of x is equal to x squared plus 10x minus 35. So again, the idea here is complete the square. So we get 0 is equal to x squared plus 10x plus 35. We want to take 35 away from both sides of the equation. Take away 35 from both sides of the equation, and we get negative 35 is equal to x squared plus 10x. Alright, now we need to complete the square over here. Our b this time is 10. Half of 10 is 5. 5 squared is 25. So we're going to add 25 to both sides of our equation, And so that now leaves us with a negative 10 over here is equal to x squared plus 10x plus 25. Now we can write this perfect square trinomial as a square binomial. X plus 5 squared is equal to negative 10. We take the square root of both sides. We get the square root of negative 10 is equal to x plus 5. So we subtract 5. Oh wait, I'm getting ahead of myself. I mean, remember that negative 10, square root of negative 10 is really just negative 1 times 10. The 10 won't get out, but the negative 1 can, because that is our imaginary unit. So this is really just I times the square root of 10. And let's not also forget we get the plus or minus over here. Plus or minus. So and then we take 5 away from both sides. We already did that. So what we're left with is x is equal to a negative 5 plus or minus I times the square root of 10. Sorry, I know that one's a little backwards there because of that little mess up. Alright, why don't you guys try this one and this one. And now we got the idea of a complex conjugate. A complex conjugate is it's kind of like we've already been working with complex conjugates. Like on this problem, our two solutions were negative 5 plus or minus I times the square root of 10. Well, the conjugate of that, one of them is the plus 1 and one of them is the minus 1. So that's the idea of the conjugates here. So in other words, the complex conjugate of a plus bi is a minus bi. And if we're given one root, we can always find the other one by finding that root's conjugate. So let's do just that. So remember, these are always written in the form of, and I'll write it over here, a plus or minus bi. And in this case, we know that this is our real part, this is our imaginary part. All right, so this time it's flipped on us. So we need to rewrite it so that it looks like it's supposed to. So we know that this is really 2i plus a negative 15. All right, so let's rewrite it into a plus bi form. So that would be a negative 15 plus 2i. All right, so that is one of our answers. But then to find its conjugate, we need to do the subtraction one. So it's oh, okay. Sorry, people are coming in. So then the conjugate of that would be 15 minus 2i. Okay, over here, last one. This one's a little tricky because it doesn't have the a part in front of it, but don't let that mess you up. It's like, so what we really have here, we have 0 plus a negative 4i. So 0 is our real part, negative 4i is our imaginary part. So to get the conjugate of it, we would have to do 0 minus a negative 4i. And we all know what happens here. This becomes plus a positive. So the conjugate of negative 4i would just be 4i. All right, why don't you try this one, and try this one, and try this one. Thank you guys for being awesome. We'll see you in class today. Don't stop rocking.